Generics in Move allow you to define functions and structs that work with different data types. They are also referred to as parametric polymorphism. Generics are commonly used in library code and frameworks to write code that can work with multiple data types. To declare type parameters in functions and structs, you use angle brackets after the name. For example, a generic function called ID takes a value of any type and returns it unchanged. The type parameter t can be used in parameter types, return types, and inside the function body. Generic structs can also have type parameters that specify the types of their fields. For example, as you can see, both foo and bar use generic types here. When calling a generic function, you can specify the type arguments for the function's type parameters using angle brackets. If you don't specify the type arguments, Move's type inference will determine them for you. In this example, we can see that the type argument is specified. Similarly, when constructing or destructing values of generic structs, you can provide type arguments. This is an example of constructing and destructing values of generic structs with the type arguments specified. If you specify type arguments that conflict with the actual value supplied, an error will be given. Here, we will get an error as the Boolean true is not an unsigned 64-bit integer. Move's type inference is able to automatically infer type arguments in most cases, so you don't have to write them explicitly. Unused type parameters are allowed in struct definitions. They can be convenient for modeling certain concepts or for future extensibility. Here's an example where we have an unused type parameter. Phantom type parameters are used to solve the problem of unused type parameters affecting abilities. They allow unused type parameters to be marked as phantom, indicating that they don't participate in ability derivation. Phantom type parameters can only appear in phantom positions and can be declared using the phantom keyword. This is an example of how the phantom type parameter is used. Imagine you have a struct called transaction with a type t, where t represents the type of transaction. However, there may be cases where you want to use the same struct for different types of transactions, but without actually using the type parameter t in the struct's fields. In such cases, you can use a phantom type parameter to mark t as unused. Here's an example. In this example, phantom t means that the type parameter t is a phantom type parameter. It serves as a placeholder for an unknown type but doesn't affect the struct's fields or abilities. It's like an empty slot that you can fill with any type later when you use the transaction struct. Why would you want to do this? Well, one possible use case is when you want to differentiate between different kinds of transactions without actually using their specific types. For instance, you may have two different kinds of transactions, regular transaction and special transaction. You can create instances of transaction regular transaction and transaction special transaction without actually needing to access the specific fields or behaviors of regular transaction or special transaction. The phantom type parameter allows you to differentiate between these two types of transactions without impacting the struct itself. Here's an example to illustrate this concept. In this example, transaction phantom t allows you to define a generic transaction struct that can be used for various types of transactions. The specific type of transaction, regular transaction, or special transaction is captured by the phantom type parameter, but it doesn't affect the struct's fields or behaviors. Phantom type parameters provide a way to create more generic and flexible code that can be used with different types while still ensuring type safety and separation between different kinds of data. By utilizing phantom type parameters, you can enhance the expressiveness and safety of generic code in Move. Phantom type parameters allow you to mark unused type parameters without affecting abilities, enabling safer operations on generic types.